When we first started this unit, we went through that table of symbols and listed some different instruments you might introduce into a circuit that would be able to tell you a little more information about it. Um, so it might be things that read potential difference or current at certain points. And you may even run into them in problems. They may be thrown in and you're expected to know what they do. So first one is a voltmeter, and if you remember, that's just the letter V inscribed in a circle. Doing the best I can here with Adobe. Alright, so V in a circle measures the voltage across a wire. It's always going to be connected in parallel with whatever element you're trying to check the voltage over. So we always know that some element causes a potential drop, so you take a before reading versus an after reading. Next element is an ammeter, which, if you remember that one, is just an A in a circle. Ooh, this is rough. Ammeters are connected in series, so the current actually has to flow through the ammeter so that it can tell you what it's going to be. These two are the most likely for you to run into, the most likely measurement tools. So if you look in this example, alright, let's see what we have going on here. It looks so busy. Alright, so we come out of the battery, we hit this parallel section, and then another resistor's in series, and run around through an ammeter back to the battery, and we have this voltmeter connected across resistor 3. So we have 9 volt potential difference, the value for resistor 1, 2, and 3. What are the values measured by the ammeter and the voltmeter? So it's just another way of asking you what is the current, the total current, and the potential drop across R3. So let's figure out first, what does the ammeter read? To do that, we will need to figure out an equivalent resistance. So remember, from combination circuits, we always want to do the parallel part first. So we have to break down R2 and R3. Alright, well, not dollar sign. So the equivalent for R2 and R3, that's going to be 1 over 5 ohms plus 1 over 20 ohms. Alright, so we do this and get 0.25, which means that an equivalent resistor to 2 and 3 would be 4 ohms. So that means our overall resistance in this circuit is 4 ohms plus R1 is 5, so 9 ohms. Let me type that out. 4 ohms from what we did here plus 5 ohms, that's our value for resistor 1. So 9 ohms is our equivalent resistance. So this ammeter, it's in the main branch. That means we figure out the overall current, and that's going to be the value. So I total is equal to 9 volts divided by 9 ohms, just 1 amp. For the next part, we want to figure out what the voltmeter says. So it's connected only across R3, but we know that the drop from here to the other side, so from one side of a parallel to the other, is the same on both branches. So we can use the information that we have about the equivalent resistance for 2 and 3 to figure that out. Alright, so what we're looking for here is a potential difference. Whoa. I wanted to see some of that stuff. Alright, so what does the voltmeter read? Essentially, we're asking what is the potential drop across 3. So remember, we're pretending that we replace that parallel section with just the single 4 ohm resistor. So whether it goes across 2 or goes across 3, it's going to cause the same potential drop that a 4 ohm resistor would. So the current that we have running through the parallel, when we add up from each individual branch, is 1 amp, 1 amp, and our equivalent resistance is 4 ohms. So that means we have a 4 volt potential drop across the parallel section, which means over either branch it drops 4 volts. Last thing you may run into, which I even highly doubt, but it's so simple to understand we may as well talk about it, are fuses. So if you have a fuse in a circuit, the only thing you really need to know is that it burns out if the current is too large. So there's some element inside of it that if the current gets too large, it gets really, really hot and burns out. So it's going to stop any other equipment from getting damaged. So if the ammeter that we had was replaced by a 1/2 ampere fuse, so a fuse that can only tolerate a current up to 0.5 amps, then the fuse would blow and current would stop flowing. The circuit would be interrupted. So like I said, it's really unlikely you'll encounter it, but since it's so simple, why not throw it in there?